Okay, so the question I did today was called odd coin flips. And I think this question was a little overrated because it felt much easier and more intuitive than I thought a medium question should be. So let's take a look at it. You flip 100 fair coins simultaneously. What is the probability that you observe an odd number of heads? So I intuitively, I feel like odd and even should come up about the same. So it would be roughly one half. And then I can further break it down into like the last coin. If I flip the last coin, it kind of the result doesn't depend on like it just kind of depends on what the last coin flip was, and it would just be a fair coin, so it would just be one half. So I can kind of break it down into a bit. So I can first think about I have the first 99 coins. I'll either be odd or even, right? That's kind of like the two states I can be in. And then now I flip the last coin. If like the first 99 coins wasn't even, then I need the last one to land on heads to get odd, right? And then the chance of this happening is one half. And if the thing was an odd number of heads, then for the 99 coins, then I would need to keep tails so that I don't add one more. So then this happens also one half of the chance. So I kind of don't really care what happened in the first 99 flips. I'm either like even or odd. So it kind of just really depends on whether or not my last fair flip of the coin, or like what the probability is. And it's 50-50, so my probability would just be one half. So that would just be my answer. And if I wanted to show this kind of more formally or rigorously, then I can kind of just rely on the binomial theorem approach. So I know that the probability of getting exactly k heads out of n flips is given by this formula. And then we can just plug in p is equal to 0.5 and 1 minus p is also that, so I get this, right? Next, for the odd values of from 1 to 100, it would just be 1, 3, 5, 7, all the way to 99. So we can kind of just break it down into 1 plus 1 to the n and 1 minus 1 to the n, because it's pretty straightforward that like the ones would generate like this kind of binomial expanded out. And then the minus 1 would create this alternating sign with the thing. And then this is evaluated by just doing 1 plus 1 is 2 to the n, and this is just 0 to the n, which is 0. So then we see that the only difference is the negative sign. So if we subtract the two terms, then the evens cancel out and we're left with the doubles, um, double all terms. So then this is what we have. If we just divide it by 2, the number we have is this. Since our previous is 2 to the 100 and now we're just 2 to the 99, we would still be at the one half chance, right? So it ultimately comes down the same, but I'd say the intuitive approach is sufficient for this problem, for sure. Cool, let's end it off here.